This is Introduction to SAS with Ryan Womack, Data Librarian at Rutgers University. This is the screencast version of our live workshop that we're making available during the time when our in-person sessions are unavailable. So I'd like to start with letting you know the major resources that we'll be using, the website that you'll need. And I'm starting out on this page, libguides.rutgers.edu/data. And we will be using SAS OnDemand for academics, which I'll show you how to get to in just a moment. So on our data libguides page, once again, if you navigate to libguides.rutgers.edu/data, you will see connections to our various data services, including links to our graduate specialists who offer numerous workshops on other topics, links grouped by software for data, where you can get to material on Python, on R, on other software. But today we're going to the software tab and we're clicking on SAS. So click on software, SAS, and you will get to the page that has other resources for SAS, as well as the two critical files that you will need to actually follow along today. So later I'm going to come back to this page and we're going to look at other resources that you might want to tap into. But for right now I'm looking at these two files, PharmaDemo data file and PharmaDemo SAS code. Those two files are the ones you'll need to follow along today. So I'm going to just right click on the link and say save link as, and I can drop it into some place like my desktop. I'm going to right click on the SAS code file and say save link as to drop that file on my desktop. So the two files that say PharmaDemo, the Excel file XLS, and the SAS code file, make sure you save those two, because those are the two things we're going to use when we actually get into the exercise. Now we're going to be using SAS OnDemand for academics, as I've got a note here in our little notepad. SAS OnDemand for academics. Now there is a web link for that, which I'll pull up for a second, but I typically just always end up Googling that, SAS OnDemand for academics. And when you click on the link there, you will get to the introductory screen describing the SAS OnDemand program. This is free cloud software for learning purposes provided by SAS. It's the easiest way, in my opinion, to learn about the software, get access to a fully working copy of SAS that you can then use for academic purposes. So if I click Access Now, I will get redirected to a page that describes how to get started. Now, if you haven't used this before, you will need to create an account. And let me be clear about creating an account. As you scroll down this page, you will want to register yourself as an independent learner. Now you may think of yourself as a student who's learning SAS, but the link for students is for course use, where an instructor has provided you your credentials to log in. If you're just watching this video to learn SAS on your own, even if you are a student, you are an independent learner. So follow these instructions. Click on the registration application. And what SAS has now done, and once you've clicked through, you'll see this unified interface. This is relatively new from SAS. And I'm going to paste a link to that here if you want to go directly to that. That's welcome.oda.sas.com. From the welcome page, if you have not used this before, you should select your region and then click register or check account. I won't go through the registration instructions in this video to keep it manageable, but they're fairly straightforward. You provide SAS with an email address, let them know who you are. They will email you credentials to log in. Now, sometimes it takes a little time for those credentials to arrive. They may not come right away. It may take 15 minutes. It may take 30 minutes. I haven't really seen longer than that, but I hope you will get your credentials quickly. If you want, go ahead and do that step now. Pause this video and come back once you've got your credentials ready. All right, so I've done two things up to now. I have visited the LibGuides page, and I've downloaded 2 files, and I've visited the SAS page for SAS OnDemand for academics to get my account. Once you have done that, you'll be able to sign in, and as you see here, I did not select a home region, so I now need to select a home region, select sign in, and that's going to take me to the login screen for the SAS Cloud services. Then I'm going to click my login, enter my password, and sign in. So obviously you need an active internet connection. This is an online service. It does give you a generous storage allocation of 5 gigabytes, so you can do substantive work here. You can't really work with gigantic data files. I'll turn a little bit later to the ways you can get access to SAS at Rutgers other than SAS Studio. But for right now, let's concentrate on learning a little bit about the SAS language. So the interface to SAS, which you would also be able to access if you had your own standalone version of SAS, is SAS Studio. This is actually a greatly improved interface compared to the interface that was available several years ago, which really didn't have a modern editing structure or feel. It takes a moment here to connect to the online system, and you'll see a relatively intuitive, if you've done any cloud work, any work in browser-based software, very intuitive sort of setup with some navigation icons at the top right, which I won't even get into. I'm really going to concentrate on the code and on the navigating your files over here on the left. On the left-hand side, and I'm going to shrink this a bit so we have even more room to look at our code, you have these other tabs that you can expand or contract that allow you to do things like save code snippets or shortcuts to library locations that you might store files, file shortcuts. Those are all things that can help speed up your work. The only thing I'm going to use for this introductory session is the server files and folders. And here I'm going to create a new folder, and I'm going to move, I hopefully deliberately step by step through this. I'm not going to repeat myself too much in order to keep the video short. So please pause and stop the video as you're completing these steps to make sure that you're following along. So I'm going to click on this icon with this asterisk next to it, which allows me to create new things. I'm going to create a new folder. Let me just call that simply demo. Actually, let me call it for today online demo to be a little distinctive. And I'll say save. And now you'll see this folder appears in my workspace. It's a good idea to have one folder for each project just to keep your workspace tidy and keep things from getting too messy or clashing with each other. So we're going to put all of our files into this online demo folder. I'm going to click on that to highlight it. Then I'm going to use the up arrow upload symbol. Again, a fairly intuitive design language. I'm going to click on choose files, and then I'm going to look around on my somewhat messy desktop here and grab the 2 pharma demo files. Once I've chosen them, I can click Upload, and there they are in the online folder. Right? So very straightforward. Any data sets that you have of your own that you want to work with on this system, obviously you'd have to upload in that manner. So in our case, this Excel file is our demonstration data, and the second file is ending in .sas is our SAS code file. Now to look at that, all you need to do is double click on it, and you'll see it is opening in a tab. I'm going to just close out my second tab just to clean up the workspace. And I have some nice code highlighting here. A SAS file is simply a text file that ends, instead of with .txt, ends in .sas, so that SAS can recognize it as a useful file. And essentially we are issuing commands to SAS that are recorded in the code file. If we were in an interactive mode on an old-fashioned terminal login, we could submit commands directly. But actually this format is, I would argue, much superior just in terms of the control and the record of your actions that happens once you've got everything in the code file. So part of learning to use SAS is just learning its own coding style, which I would characterize as a kind of old-fashioned style. It is not terribly flexible, at least for the base SAS. It consists of well-defined code chunks where everything has to be in a certain place, and it doesn't allow you to free-form program in the way you might be used to coming from some other scripting language like a Python. However, even with this structure, it is quite powerful for statistical purposes, and it's quite predictable and reliable. So these are strengths of the SAS system that are quite good for reliable, consistent statistical analysis. All right, so you'll notice the content in green are human readable comments. Those comments can either be prefaced in a block by this /* equal sign, and then ending with also the /* at the end. That sets off an entire code block. We can also set off an individual line as a comment by just putting the asterisk for that one line. You'll notice if I remove this, the green goes away, and that becomes an unrecognized command. You notice that it's just in gray right now. This is the kind of thing that if we ran it would generate an error because it's not actual SAS code. But the green is just there to provide you some guidance to what's going on in the code as we go through. So I'm going to step through this code, and I'm not going to talk about every single line of the code because this example derives from a case where the original audience really wanted to get into the data itself and analyze many different variables in the data. We're going to be more selective than that. So just to let you know that I will be skipping over certain lines of the code. And others I'm going to just talk about without running them. So the first one of that type is line 13. So again, this is an introductory workshop. We're not going to go into great detail, but I do want you to be aware of this concept called the libname. The libname is a way in SAS of specifying a shortcut, a short pathway to your data with a consistent name that could then be referred to throughout the code. Lots of programs, SAS programs, use this because it enables you to be flexible about the data source. You can write code that will work when pointed at multiple different hosting sites for the data, simply by editing the libname command once at the beginning. But for this simple example, we don't need a libname, so I'm not going to run the command in line 13. Let me further be clear and say, when I say command, I'm really talking about the stuff that's highlighted in blue or dark blue. Those are the SAS commands that SAS recognizes. All right, so moving forward, we want to actually import our data set. And I'm going to talk about that again first before doing it. In lines 15 to 18, I give you an example of if we had a plain text data file, we could read it in with what's known as a data step that says data, names the data set, and then the file that's brought in. In this case, we have an Excel file. So we have to convert or import that Excel file, and in this case, SAS considers that a procedure, not a data step. And here I'll pause to say, when you're working in SAS, 90% of what you do, if not more, are either procedures or data steps. Procedures being the proc that's here in line 22, or the steps that begin with data. So either it says proc or it says data. Our first example of that here is Proc Import. So that's a procedure to import data. Proc Import. The stuff in dark blue are the sort of top-level main SAS commands. Proc Import expects to see certain things, and those are the things highlighted in the medium blue color here. We need to tell SAS what is this data set going to be called once we've imported it. So the output or out is my data. We're just calling this data set my data within the SAS environment. We need to tell SAS where is the data coming from. This is the data file. We also need to tell it what format the data is in, which is the database management system DBMS equals XLS. That's the part of the statement that tells it that this is an Excel file. And finally, we say replace to indicate that if we had already got something called my data in our workspace, when we run this command, we're just going to replace it or overwrite it. We're not going to say, oops, there's already one like that here, and stop the command. You don't have to have that replace command, but be aware that if you ran this command twice without the replace command, you generate an error. Okay, another key SAS programming construct is the semicolon. The semicolon is used throughout SAS code to indicate a stop, an end place for a particular code segment. So the basic proc import command runs from line 22 to 24 with a semicolon at the end. Afterwards, we can add additional options. And here, in this case, we do that. We say get names equals yes, which means take the variable names from the data set. In an Excel file, we actually have multiple sheets within the Excel file. And we need to sometimes be careful about which sheet we are grabbing. So this is grabbing the sheet from the Excel file, which actually has the name CSV. That's, in this particular example, CSV is the name of the sheet in the Excel file, not a data format. And also, we're letting SAS know that the data itself begins on row 2, because all of the variable names are in row 1, and all the data is in row 2. So you do need to look at your original file and examine it before you make those determinations. And you may need to modify those things to get your options, to get the data imported correctly with those options. All right, now there are 2 places in this code, actually 3 places where the file name must be changed if you're going to have this code work for you. The one place which we're not running is line 13, so I'm going to skip that one. I'll just write here, ignore this part. The next place is critical for us to get our data to come in, and that's the data file. Now, your account name in SAS is going to be something different. You're going to have a structure like home/your name here, and pharmademo is a directory name that I had used in the past. That's not going to be your name. It's going to be whatever you just created, followed by the file name. Now, the easiest way to get this information correct is to go to the file that you want to import, which is our Excel file over on the left, and right-click. And if you scroll down at the bottom of the right-click, you'll see Properties. That will show us the current path to the file. So this should have your directory and folder information when you pop it up. So I'm just going to copy that, close it, and I'm going to stick that in between the quotes in this purple part. So the purple in the text is the user-defined locations text outcome. So I've made that change. Definitely go in and make that change on line 23. Right-click on the pharmademo's Excel file, go to Properties, look for location, and then copy it and import it. Copy that, paste it in on line 23 between the quotes. Okay, now we've made that change, we should be ready to go. We're finally going to actually run some SAS code, so let's take a look. To run the code, I want to highlight everything from line 22 to line 28. Just use your mouse and highlight that in the SAS Studio. The run statement at the end is a very clear way of letting SAS know that that's one chunk of code that needs to be executed all at once. That is a convention in SAS that's been around for a long time. Over time, the necessity of including the run step, the run statement, has diminished. Some commands run just fine without that, but you'll see it in a lot of SAS code, and I'm preserving that in these examples to let you know what that looks like. It's also a kind of useful notation to you as the runner of the code that defines a section. And again, that ends with the semicolon. Okay, so I've highlighted this. How do I run it? What do I do? In SAS Studio, you want to look for this little icon at the top left. That's a little running person. You can click on that, or if you get used to the shortcuts, you can just hit F3 when you want to run. Now, I'll caution you again before running this. If you don't highlight the code section that you're interested in and you hit run, you will end up executing the entire window of code that's in front of you, the entire file. That's not useful until you have worked out all the bugs in your code. And if you've worked out all the bugs in your code, you know, okay, I just want to get straight to the entire results, spit it out all over again, you can do that. But we want to be careful for this demo to highlight only the section we're interested in. So I've highlighted 22 to 28. I'm going to hit run. And now we have something that looks like success here, which is it has imported some data and dropped us directly into an output window that lets us start to browse that data. We've got 200 rows of data displayed 100 at a time on the screen, and we can actually browse around and get information. So that's a very good sign. But what I also want to emphasize throughout this is that always take a look at your log tab. So another thing that SAS Studio does really well is give you this easy ability to toggle between the tabs at the top of the code. What is the code window if you click on code, but just our output window in general. We can toggle between code, the log, the results, which we'll see in a bit later. We don't have any results yet, and the output data. So our log in this case tells us that these lines of code have been run, and this is what happened. A data set was successfully created with 200 observations and 11 variables using this much resources. Now, the fact that this is all in blue is a good thing. Blue means success, no problems. When we have problems here, we will encounter errors and warnings. And I'm just going to generate an error for you so you see what that looks like. If I had made a mistake in my data path, for example, instead of rwomack 0, which is my account, my actual account, I had used rwomack, and try to run this chunk of code, I will get a red error message. Physical file does not exist. It can't find anything at rwomack, and the SAS system stopped processing. Right? So that's what a bad outcome looks like. It will drop you directly into the log if it doesn't have any successful output to display, but once again, it's a good habit to get into, to be looking at your output, at your log output, to find out what's going on. So since I made that mistake there, I'm just going to rerun the chunk of code so that we get the correct data, make sure everything is back and running. You'll also notice since I made a change, I've got a little asterisk next to my pharma demo. I can hit the save button, make sure my changes have been saved. Okay, so I hope you've run your first SAS command successfully. Let's keep going through this code, and we'll move more quickly as we get accustomed to this process. So line 32, what's happening here? Line 32 is something called the output delivery system in SAS. Now, because SAS has been around for a long time, back to the 1970s, for a long time, the output that came as a result of any SAS command was very, let me call it rough or unformatted, and basically, text dumped to the screen or dumped to a file. SAS developed something called the output delivery system so that the output would be a bit more polished. And the output delivery system can generate PDFs for you, it can generate HTML files. In this case, we're using it to generate an RTF file, which is a Microsoft Word and other word processing compatible format. To initiate this command, we say ODS and then the format, RTF, and then where are we going to put this file? So this is the second place that we need to change the directory. Here I need to change my folder to online demo. So just copy what you have done in line 23. You can actually copy that whole chunk and paste it in between the quotes, except with one change. You don't want this to say XLS, you want it to say RTF, because we're actually generating new output here. We want it to be in RTF format. Now you'll notice here I used, instead of double quotes, I used single quotes. That's one syntax thing that doesn't really matter, doesn't make a great difference within SAS. So you can actually use the one that you prefer. All right, so I'm going to highlight that part of the code, line 32, run them, and here I will get, if my directory is correct, I'll get a blue statement saying that it's now writing to this file. We're going to see what that file becomes at the end of the session, so we're going to get there. Now, lines 35 and line 35 and line 40 are fairly straightforward commands to simply display the output in your data. If I do line 35, this is a procedure, proc. It prints. So proc print simply prints out the entire data set. And which data set is it going to be? It's going to be my data. So proc print data equals my data. If we run that, what we actually see is the entire data set is printed to the screen, all 200 rows, and this is also going into our output file. Now obviously you don't want to do this on a gigantic data set, but for smaller data sets it might be useful just to get a look at the data, make sure everything is correct. Proc contents is something similar, except that it simply shows the variables defined in the data set and their characteristics. So the contents procedure tells us a little bit about the working environment that this data was used in, and down at the bottom a table of the variables, whether they're numeric or character, labels assigned to them, etc. Now, why do we say data equals my data? Well, we have to do that every time because SAS assumes that it makes no assumptions that you're working with just one data set. You can work with multiple data sets in SAS. This is one of the strengths of SAS. But we do need to tell it every time which data set we want to use. So in this example, we're not getting fancy and pulling from multiple data sets. However, you may want to modify your data. And so I'm going to, in this section, take a little bit of time to talk about the data step. The data step is commonly used, one of your major SAS things. Data step is used to modify, create variables, drop variables, modify labels. So let's quickly look at some of those things illustrated in the code. In line 45, we're going to have a data step that's going to create something new called my new data. It's going to replace my new data if my new data was already sitting around in our workspace. And in line 46, we tell it which data set is this going to be based on. So we're going to take the my data that was imported and use it as the basis. What do we want to do? Well, we're going to drop one variable. We don't need this painkiller variable. Now, I'm going to refrain from talking too much about the meaning of this data set, but it's 200 observations of hospital patients, their length of stay in the hospital, and how much opioid drugs they were administered is the primary interest of the data set. But we are not interested, let's say, for example, we're not interested in the painkiller variable. We can get rid of it with this drop statement. We can also change the labels of our variables. So to give them something a little bit longer, more human readable, we say label, the name of the variable, and then an equals, and then provide the new label that we would like to use. Now notice there's not a lot of parentheses or other sort of syntactical cues. We simply list out the variables. Even with spaces, SAS is going to wait until it sees the next actual variable name with an equals to move to the next step. So we're not even putting quotes around the labels, total opiate use or opiate naive tolerant, but SAS can handle that. So it's, except for the constant use of the semicolon, I would say SAS is somewhat devoid of punctuation. All right, let's try running this. So from line 45 to 49, highlight that and run it. And now we can see, actually we don't see it immediately, but if you highlight a particular variable like OPNT, you'll notice down at the bottom left, we can view the new label that's been provided, opiate naive tolerant. So we can see that that command did have some effect. We can also check it in the log to make sure that there was no error or warning that appeared. I'm also going to rename some variables. So this lines 50 to 53 has the same format. Here I'm just iterating on my new data. I'm taking as a basis my new data and replacing my new data with this modified version. And I'm renaming a couple of the variables. I'm going to run that. And then finally, so we can also see that our names of the variables have changed a bit. And finally, I'm going to create a new variable. To do that, we simply define it in the data step. So I'm going to say hourly dose equals the total opiate use divided by the length of hospital stay, which is what that abbreviation is for. And run again. Again, because it's a data step, it's showing us the data. And I can scroll over to the right to make sure that, yes, there is a new column for hourly dose, and those computations now appear in the data set. We could also confirm that by running a proc contents command, which I will do in line 59, which will show us the list of variables that now includes hourly dose. These are actually in alphabetical order, so even though that's the variable number 11, it appears sort of in the middle of the list. Okay, so that's all I'm going to talk about with the data step, but I think this gives you an idea that yes, you can modify your data set within SAS. Now we're going to turn to the statistical side, and we will start calculating some descriptive statistics. So everything in these sections revolves around different procedures, different proc commands. And it's a question of knowing which ones to use to get which kinds of output. So after I demonstrate a couple of these, I'm going to show you a little bit more where you could find out information about that. So line 64, Proc Univariate. Now, as you might imagine, that allows us to get information on one variable at a time. We, again, need the data statement. Which data set are we looking at? We're looking at my new data. And which variables do we want this information for? So there's a var statement, after which we list the variables that we're interested in. Total opiate use, and total length of stay in the hospital, which is abbreviated TOT-LOSH. Okay, I'm going to run that. And we have, 200 observations, a mean for looking at total opiate use to start with, a mean of 36, a standard deviation of 32, and then it goes on. We've got skewness, we've got kurtosis, we've got tests for location, like the student's T-Test. We've got very detailed quantiles defined for the data. Extreme observations are mapped out. So this is quite detailed, and this is typical of SAS output. That SAS output leans to being very detailed, leans to providing a very complete statistical representation, and it also, in base SAS, cannot be modified. We can't say, you know what, just show me the mean. Not really the way that SAS works. This is a feature from the point of view of how SAS is designed. SAS is popular in pharmaceutical research, in healthcare research, in FDA drug applications, partly because the end user cannot really fudge the output by selecting only the highlighted variables, statistics that make their case. They just sort of have to show, here's all of the output. And an expert reading that output would know which of these things do you want to look at. Do you care about kurtosis? If you care about kurtosis, you can always find it in the same place on a SAS output screen. So this is typical of the style. We'll come back to that again in another context. Now, if I want to compare two groups, that's a little bit easier using the proc means command, illustrated in line 70. Here we're also interested in these variables, but we want to compare two groups. So we've introduced a new statement on line 71. That's class. And we are going to class the data by the IV status. Did the patient receive an IV or not when they were in the hospital? So we can run that. And here the output is not as elaborate. It does just report the mean, standard deviation, min, and max. But we have two groups, the zeros who did not receive IV and the ones who did. And we can see there is some difference in their opiate use. Now, it's typical in SAS that for certain kinds of procedures, it's highly recommended to sort the data beforehand. This is a legacy of SAS's. SAS has been around for a while. Back in the days when memory and storage were at a premium, a lot of the procedures were designed to be very economical. And one of the ways they did that was by sorting the data and then running the calculations on all the similar data together. This, in today's world, has had a side benefit, or an unexpected benefit perhaps, that SAS works really well with big data because it was designed to be economical a long time ago. The way the procedures work, they handle large data sets quite well. In other software like R, the typical limitation is that the data must fit in the computer's memory, allowing for some extra leeway for copies and computations to be run. SAS doesn't have that requirement. SAS can operate on large data sets off of the disk and still function well. But that is connected to the fact that sometimes you need to be careful in how you structure your commands. So in line 78, I know I'm going to be interested in things grouped by the IV status, so I'm going to sort the entire data set by the IV status. This is proc sort, and we simply say by the variable that we'd like to sort by. So pretty straightforward command, line 78, I'm going to run it. We've now sorted the data, and we can check that the IV status is 0 for all of the first 100, and when we go to the second page, we have 100 cases of IV status of 1. And once again, always take a look at your log, make sure that you're still in the blue zone with no problems. Okay, so let's look at a couple of typical statistical tests that you might be interested in running. The chi-square test, and then a bit later we're going to look at the T-test. The chi-square test is accessed in SAS via a sort of back-end method, not an immediately obvious method, but because the chi-square test measures whether the distribution in a table of data is random or deviates from what could be generated by a random process. It's actually a sub-option of the tables command, which appears in proc freq. Proc freq is the procedure that deals with frequencies, tabulation of frequencies, right? So we say proc freq, data equals my new data. We would like to generate a table of the IV status cross-tabulated by epidural drug, epidural status, meaning did the patient receive an epidural or not. Only after we have set up that table do we then ask for the chi-square measures to be provided. So this is a little bit of a new format of a command, but this slash means, hey, I'd like to also see some optional extra stuff. In this case, the chi-square measures. All right, so I'm going to run 84 to 86, and we'll get a look at what that output looks like. Okay, we've got the frequency procedure. We've got, of the people who did not receive an IV, about 52 did get epidurals, 48 did not. Of those who did have an IV treatment, 97 out of 100 got an epidural. So clearly there looks like a strong pattern in this data. It doesn't look random. We can confirm that by the chi-square statistic, which is reported in the next batch of next little table here. P lower than 0.0001 is really quite low, so very significantly non-random. Now you'll notice what else is here, right? A lot of other stuff. SAS likes to be complete. There are actually many different versions of the chi-square test that can be invoked, some slight methodological differences. Here they're all significant, but a particular person might be interested in just looking at one of those or emphasizing one of those. So SAS shows them all to you. The regular chi-square, the Mantel-Hansel chi-square, and lots of other stuff. As we go down, we've got even more coefficients, right? And we've got the odds ratios calculated. These are all things that certain portions of the audience might be interested in. SAS just gives it all to you. And you learn to pick out from the tables those statistics that are of interest to you or to your research. Now, and we'll see it at the end when the file comes back, but one of the key benefits of using the ODS step that we did up in line 32 is that output file is going to have all these results in Word format for us, and we can then cut and paste the parts that we need into some other report. Okay, now in this, I said I was going to skip a bit. This is an example where the same chi-square test is run against different variables, against the opiates, against the tramadol, whether patients receive tramadol. I'm not going to run those. You can run those as extra practice if you're curious. So let's see another side of the analysis in line 97. We saw Proc Univariate before. It let us compute the mean and the standard deviation and some other statistics. But we can also use Proc Univariate to get some plots, get some graphs. In this case, we're interested in finding out whether the data is normally distributed or not. So we're going to invoke some other options. Instead of just having the var statement, we're going to also add this little normal option. It's going to invoke some additional statistical tests of normality, and we're going to ask for plots. The QQ plot and the probability plot are ways of seeing whether the data is normally distributed, and those can be just asked for as options to the Proc Univariate command. Notice here I'm not ending with the run statement either. As I mentioned, the run is not strictly necessary, especially these days as the code has become modernized. So I have sort of left off the run statement here just to show you that that works. It really is, in many cases now, a matter of personal preference whether you want to keep the run statements that are traditional in SAS code or drop them off. So here's our new univariate output. We've got the same stuff we got before, the mean standard deviation, but we've got these tests for normality that have now appeared. The Shapiro-Wilk test, Kolmogorov-Smirnov test, right? So other things, and if you're not interested in those, just ignore them. But it's all there if you need it. And notice now we have these plots, right? So the idea of both the QQ plot and the probability plot is that it should be roughly a 45-degree line without curving tails or strange distribution to show that the data is normally distributed. And this looks roughly normally distributed based on these plots. This is the first time we've seen SAS provide graphical output, and we'll see a little bit more coming up. Okay, next test, T-Test. So this is fairly straightforward. T-Test is Proc T-Test, so this is a test that has its own separate procedure, a little bit easier to handle. The T-Test can compare two different groups, whether they're significantly different. So we want to compare again by the class of IV status for different variables. The first one being weight. So lines 103 to 105 will allow us to run a t-test on weight, a two-sample t-test comparing the IV versus non-IV populations. And I'm going to click Run. And here's our t-test output. Right? So we can look at the significance levels, once again providing you with a few different options, the pooled and the Satterthwaite methods, neither of which show a significant difference. And here we've also got some diagnostic plots thrown in automatically to let us see whether the data is normally distributed. The red curve is the actual distribution of the data, and the blue curve is what it would be if it was perfectly normal. So we can see that it is approximately normally distributed. There are several other t-tests for other variables, which I won't run. You can try them out just to get familiar with that. That's a two-sample t-test. If you're curious about a one-sample t-test, that's illustrated in line 120. And here we are testing whether one variable is significantly different from some null hypothesis. So here I'm stating that my null hypothesis, my H0, is 70. Is the actual data, in the actual data, is the length of hospital stay near 70 or not? And then I'm asking for some other options. Show the plots with the null hypothesis. Unequal sides are allowed, and a alpha of 0.1 means show me the data for a confidence level of 90% instead of traditional 95%. So that's also just to show you that we can invoke some options to modify our data. And let me highlight that section and run it. So this is what that looks like. Again, not significantly different than 70p.46. And then we also get our visualizations of the data, just to show you something a bit different. Length of hospital stay does not really conform to a normal distribution, as you can see. Okay. I'm going to keep running straight through. I would encourage you to pause if you need a break, but to keep this as one big but relatively short video, I'm going to keep rolling. All right, so we have two major things left to look at. We have graphing and we have regression. Now, first of all, I'm interested in graphing some box plots of our data, and I'm interested in, is there a difference between those who got epidurals and those who didn't? This is a new category, right? So I need to sort my data again. Line 126, proc sort by epidural. And most of our standalone graphs, now we've seen a few graphs that have snuck into our other commands. Most of our standalone graphs come from this proc sgplot. Proc sgplot allows you to invoke various graphing types after you've run the proc sgplot command. So line 131 to 133. Line 132 is where the action is describing the graph. This is a VBox, a vertical box plot, where I'm graphing total opiate use by the category epidural. You really need a categorical variable here so that you have your boxes grouped by something meaningful. So we can actually see that the total opiate use is overall not terribly different in the central range, but that there's a lot more outliers of high opiate use among those who had epidurals. Right? So another way of looking at our data. We might want to explore relationships between variables, and we could do that in line 137. We could get a numeric representation of that by looking at the correlation between two variables. That's proc core. Proc core, just list our variables, run it. So I hope by now you're getting really comfortable with the SAS syntax, the way these variables are tersely thrown together. The correlation between those two, 0.29, 0.295. And it gives you a correlation table, right, that's here. So obviously the correlation between a variable and itself is 1, and then the diagonal axis shows you the correlation between the others. If we added more variables, we could get an entire correlation matrix there. So we see there's some relation, not like lockstep or super strong. We could visualize that with the scatter plot. So once again in line 144 we see proc SG plot, and we have the graph type of scatter, and we simply define what's on the x-axis and what's on the y-axis. Run that, and a sort of fairly standard scatter plot. We can see a lot of people with a lower average pain score, and we can kind of see this sort of upward trend that the high opiate use, high pain is, it lifts off away from the horizontal axis, right, which accounts a bit for our correlation. Okay, I'm going to take a little detour before we do regression right now and go back and talk about how do we find out about all this, what's in these SAS commands. I mean, I've been telling you about the SAS commands, but where does all that come from, right? Where did it come from? So I'm going to go back to our data services page. Once again, libguides.rutgers.edu/data, and show you down at the bottom. Oh, sorry, I do need to go back to the Software SAS tab. Scroll down to the bottom, and you'll see Sass Documentation. Now there's some other tutorials here. I would encourage you to just explore some of the other things on this page, but the Sass Documentation is really critical, right? So a lot of times the official corporate documentation of something is very dry and not very useful. You often find yourself looking for something a bit better. I'm a big fan of the SAS documentation. SAS documentation lets you just search for a particular procedure or a particular concept and find out where that's implemented in SAS, in which procedure. But here I'm just going to search for Proc Univariate to give you one example. So Proc Univariate, each procedure, each proc statement has its own page of documentation that's really nice and complete. So how does this work? We have an overview that is a general description of the statement, and it will talk about how that works. Sometimes the statistical underlying concepts that are there, other things it might relate to. That's the overview. The getting started. So I'm clicking on these tabs, the horizontal tabs. There's also navigation on the left-hand side in more detail, but I'm clicking on this gray bar right here. Getting started shows you from the beginning what is going on with this procedure. And here are ways we can do some basic examples and see what the output looks like, right? So getting started, a great place to get started, obviously. If we need to go into the full syntax, now I showed you a few of those options that we could pull in, like the prob plot and the QQ plot, but there are many things, right, that in each of these SAS commands that could be invoked as additional options. So when you're at that point of really needing to know how does the syntax work, you can get details about each aspect of the syntax. The Details tab is actually really more about the advanced statistical considerations. So that's really detailed, right? When you go in here and you look at the discussion of descriptive statistics, here's how the mean is calculated. Here's how the variance is calculated. Some of that is like statistical basics, but SAS wants to give you everything, all the tools you need to understand their output. And finally, I think, one of the places I often go to first, if I just need to quickly solve a problem, is the examples, right? So the examples show us using this command. These are all things I can do quickly. I can add a normal curve to a histogram. Click on that. It's going to give me a working example with code of how to do that. So I'd know how to get output like this. And if I had done in my initial search of the documentation, like adding a normal curve to a histogram, that's the kind of page that it would take me to. So I think this documentation is really great because it's got the beginner and super advanced level all in one, easy to navigate, lots of good examples. I really encourage you to take a look at the SAS documentation. All right, that's my detour away from my code so that you can find out how to learn more about SAS. All right, now our final topic is regression. This is pretty straightforward. Proc Reg is the major procedure for just standard linear regression. There are other procedures for GLM, for generalized linear models, and many other regression techniques are implemented. You can access those. But we're just going to look at Proc Reg. One other thing they recommend about regression is the use of this quit statement, which you see on line 156. Quit definitively clears out any internally stored computations that are in the SAS session. That's something that the reg procedure in particular uses. They recommend that you do that after a regression just to avoid any sort of errors creeping in. Now, I'm not exactly sure what breaks or how badly it breaks if you don't use that quit statement, but that is a recommendation. You'll see that when you investigate SAS code. All right, so let's run our regression. Proc reg data equals my new data, just like we always do, define the data. Very simply, we specify a model. Now, the model has the response variable or dependent variable on the left-hand side and the independent or explanatory variables on the right-hand side. Here we just want to understand, is total opiate use related to or explained by the average pain experienced by the patient? And so I'm just going to run 153 to 156. And we have a table with the parameter estimates, the significance levels of those parameters, the standard error, R-square, all the things that you typically see in regression. Output is all here, plus a nice compact graph that includes a lot of our things that we'd look to assess the fit of the model. So we can see there is some deviation of residuals sort of at the edges of the data. This is always a judgment call of how you decide is the fit good or not. Obviously, if you're comparing multiple models, you have a better way to make those comparisons. But SAS gives you all of this information by default for regression. So again, pretty good, pretty sophisticated output. If we did want to run a multiple regression, we can just add additional variables out to the right-hand side of our model statement. That's not a problem. And I usually wrap up the in-person sessions at this point. I'm going to go ahead and give you a little bonus, which is the logistic regression section of the code up through line 177. Here in the original data, epidural is a text variable with a yes or no. In order to incorporate that into a numeric regression, we need to recode it into a 1 and 0. So that's what happens in line 161 to 166. Make sure you run that step. And we can confirm again that everything happened as we expected. I can incorporate that new variable into the model, into just a linear regression model by adding it out to the right-hand side in line 169. So I'll go ahead and run that for completeness. And now we have two different variables. Epidural is not significant when incorporated in this manner, but for discrete outcomes, like a yes or no outcome, we often want to model things with a logistic regression method. So there is a Proc logistic. We just invoke that. Now, once we invoke it, the model statement really is no more complex than a general linear regression than a Proc reg. But here we want to model the IV status as a function of pain and weight. And again, just to show you a variant regression, that's also possible in SAS, that given the nature of logistic regression, the output is somewhat different. The way it computes the parameters a bit different, and ultimately we focus on odds ratios a lot of times with logistic regression to understand the impact of these of the variables on the choice that's being made. So you can see here there is no plot fit diagnostics because those aren't as standardized for logistic regression. We get an appropriate form of output for the procedure. And that's true, throughout SAS. Right? SAS prides itself on being very statistically thorough, statistically reliable, and the very fact that these procedures are encapsulated in a Proc logistic and not left up to the user to sort of program ad hoc, which sometimes happens with other statistical approaches, has the benefit of ensuring that they're being used correctly for the most part. All right, so that's the end of our demo of code. Couple of final steps to wrap up the session is we might want to save the data. That's in line 182. SAS has its own strange format for data, which we'll see the extension in just a moment. And if you do want to save your data at this stage, make sure you change the file path in line 182 to the one you've been using throughout. And I'm just going to say data based on set my new data, save something called pharmademo. Now when it goes to save it, it saves it in the SAS native format, which is, you can see here, SAS 7 BDAT. That's SAS version 7 binary data. It's a very odd file extension that you'll only see in SAS world. But that's a file that can be used by SAS without any special importing procedures. So once you're working with something for a while, you might want to use that. You'll notice that if you just click on it in SAS Studio, it quickly opens the data without any additional steps. Okay, let's go back to our code. And the final line of code, line 187, remember way back at the beginning in line 32, we had opened up the ODS file, the output delivery system file. If we opened something, we've got to close it. So we're going to close it with the statement ODS RDF close, RTF close. And that will confirm in the log that it has run, and now our RTF file is sort of encapsulated. We can use our download option to actually download that file and take a look at it. So give it a second to open up. The advantage of this, once again, is that everything that went into our results screen has been dumped to this file, but in a nice Word format that we can edit, cut and paste. So it's both a record of our activity and something we can feed into further output. Now I want to scroll until I see some graphs. So you can see our tables that we generated are all here. As we get to the middle of the session, here we go. So here's one of our plots, just to show you that the plots appear also. Some of the, the sort of default blue coloration is lost in this format in some graphs, but obviously not in others. It's more of a monotone, one color approach. SAS also does not let you adjust the graphs very much unless you use add-on modules, which are not typically present in our academic subscription. And that's, again, from a scientific research, from a reliability point of view, that's a plus, because no one is messing around with the way that the graphs display. Okay, so I hope this has given you a good sampling of the look and feel of SAS code. I hope that it's exposed you to some of the useful procedures and methods that you might want to consider if you're using SAS, and I hope that it's given you an exposure to the SAS Studio environment as well. If you have any questions, feel free to reach out. You can find me via the LibGuides page. Email me to set up an appointment. We can also schedule a virtual meeting via Zoom. But in general, you can look to the Data Services page for announcements about upcoming training, workshops, and events related to statistical software. Thanks for listening, and hope you find this useful.